Hello, my name is Piero, and I would like to talk about my first and most exciting research project, cell culture in a biomaterial made of pectin and alginate. So let's start with some facts. It is known that some people need organs or tissue transplants, either by the loss of functions or accidents, congenital problems, but obtaining these tissues or organs from a donor brings with it some other problems, such as non-compatibility or rejection by the receiving body of the donation. To avoid this problem, the scientific community has developed a very promising field, 3D bioprinting. The principle is simple: to print a scaffold made of a biomaterial cultivated with the patient cells, so the cells can grow and replace the material with living tissue. Then you transplant the tissue into the patient, and since they are the same cells of the patient, we no longer have the problem of non-compatibility. However, there is still a problem: cost. The bioinks available in market are really expensive, so the objective of the project was to develop a bioink with but the same biocompatibility, physical and structural properties, but with low cost materials. So after a year and a half of work, we made a bioink with those properties made of pectin, alginate, and collagen. The biocompatibility was measured with a biotoxicity assay, and the bioink keeps its shape after cross-linking with calcium chloride to make it solidify. But a long time project also means a long time having problems. The first was the loss of our first cell culture, HCC70, breast cancer cells. We didn't have money to buy another cell line, so I decided to use my mononuclear cell from my blood to continue the project. The first 5 cultures got contaminated before we did it right, but we learned how to work under sterile conditions. Throughout the rest of the project, there were always problems. The bioink was too acid. I proposed to use calcium lactate to do the cross-linking. The bioink took off after cross-linking, so I proposed collagen bed to help the bioink fix at the base of the petri dish. So many times I had to take the role of the team leader. Almost always after something went wrong, some students left the project. Currently, I'm the only one of the team that started the project that is still working in it. This made me grow and develop a very strong sense of responsibility. The project is still on course, and now the team is working with chicken fibroblast and seeing if the cells could proliferate inside the bioink, and training other group with working with 33 mouse fibroblasts to repeat the biotoxicity assay. Being part of this project, I learned a lot about cell cultures and biomaterials, how to read and understand papers, to do research, but most importantly, I learned to never give up when things go wrong, because it's in those moments when the project needs you the most. It's okay to fail sometimes. Fail is just another way of learning. Thanks to failing, I learned to be patient, to do project planning, to stay curious about the future, and to build strong teams in my current projects. This project definitely was an amazing experience, enriching my skills as a student and as a person. Finally, thank you very much for choosing me in the first stage of the REPU program. I hope to see you again.